Hi everybody! On today's show we translate expressions from English into algebra. So today we focus on how can we take English words and turn them into algebraic symbols. But before we get started on that, let's review what we did in the last lesson. So pause the video and try this opening exercise. So Michael borrows money from his uncle who is charging him simple interest using the formula I equals P times R times T. So I'm working with the formula I equals PRT. Rearrange the formula to get R. So I want to get R equals. So how do I get R by itself? So I notice I don't see any adding or subtracting here. So how do I get rid of times P? I divide by P. How do I get rid of times T? I divide by T. So I need to do I divided by PT. That gives me R. And there we go. So translate each of these following statements into an algebraic expression. So write a calculation and a result that represents a number that is 5 greater than 3. So write a calculation that is 5 greater than 3. So hopefully we all know the answer is 8, but I want to know how do I do this? 5 greater than 3. So I'm at 3, and I want to be 5 greater than it. So 3 plus 5 is 8. Notice that I started with the 3 there, because 5 greater than 3. I'm starting with 3, I want to be 5 greater than it. Write a calculation and a result that represents the sum of -3 and 8. Well, sum means add them together, and I get 5. Let's slide over here. Write a calculation and a result that represents a number that is 2 less than 9. So just like with greater than, I want 2 less than 9. The answer is 7. What did I do to get 7? I did 9 minus 2. Notice, when you work with less than, the order changes. We need a little warning light to go off whenever we see a less than. A warning, 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 warning. Whenever you see less than, it's a subtraction problem, but you've got to work backwards. 2 less than 9, start at 9, and I want 2 smaller than that. So 9 minus 2 is 7. Write a calculation and a result that represents the difference of 20 and 12. So difference just means subtract. 20 minus 12 gives me 8. It's only the key thing here is this less than that we need to keep our eye out for, because that's the one that messes us up the most. You gotta start backwards and work forward. So 9 minus 2. If x represents a number, write an expression that represents a number 10 greater than x. I want 10 greater than x. Well, here's x, and I want to be 10 greater than it. So I'm going to add 10. That's my expression that's 10 greater than x. If n represents a number, write an expression that represents a number that is 5 less than n. So again, less than, warning, warning, warning. We're starting at n here. I want to be 5 less than that, so I'm going to subtract away 5 from it. Be careful when you work with these less thans. We start with the second and work our way back. Write an expression for a number that is 5 times greater than 2. Not 5 greater than 2, 5 times greater than 2. So here's 2, and I want to multiply it by 5. 5 times 2. If n represents a number, then write an expression for a number that is twice n. Well, if I want to twice something, that means I'm doubling it, which I'm just going to write as 2n. If I wanted to triple something, that'd be times 3. So twice, triple, quadruple, half, all of those is a multiplication times n. If x represents a number, then write an expression that is 3 more than twice the value of x. 3 more than twice the value of x. So 3 more than, I'm adding 3 to something. 3 more than what? Twice the value of x. That's 2x, and I want 3 more than it, so 2x plus 3. If n represents a number, write an expression for 2 less than 1/3 of n. I want 2 less than what? So I'm taking away 2 from something. 1/3 of n. So I can write 1/3 of n, or I can just do n divided by 3 minus 2. Either one of those works. 1/3 of n, and I'm 2 less than that. But not too terrible. It's not that bad. Careful here. If x represents a number, write an expression for 3 times the sum. So I'm doing 3 times the sum of x plus 10. I'm finding the sum, and I want 3 times the sum, so I need parentheses around that. It's different than the one above it, because I'm twice the value of x and then added 3. Here I'm finding the sum, then doing 3 times that, so you need that set of parentheses there. If t represents a number, write an expression for 7 less than, so I'm subtracting 7 from something. Well, what am I subtracting it from? 4 times the difference of t and 5. So I'm doing 4 times a difference of t and 5. 4 times the difference, and I want 7 less than that. So my final answer, I'm just going to do that in blue. That is my final answer there. 4 times t minus 5 minus 7. 7 less than, that tells me I'm subtracting 7 from something. What am I subtracting it from? 4 times the difference. So 4 times what difference? T minus 5. Consider a rectangle. So we're going to use these translating skills to deal with word problems. Consider a rectangle. Here it is. There's the rectangle I'm considering, whose length is 3 more than 5 times its width. So the length is always becomes an equal sign. 3 more than 5 times the width. So I'm doing 5 times the width, and I'm adding 3 to it. 3 more than what? I'm adding 3 to 5 times the width. So if this side is 5w plus 3, and this side is 5w plus 3, that's the length. These other sides are the width. The length, this is L here, which is the same as 5w plus 3. It's 5 times that, and add on 3. Write an expression for the perimeter. We talked about in the last lesson, perimeter is the total distance around it. So the perimeter, I want to add it all up. I want to add up all the sides of the triangle as if I was walking around it, collecting them all up. So you could write w plus 5w plus 3 plus 5w plus 3. Or just think about it. How many w's do I have? 5, 10, 11, 12, 12w plus 6. So you get when you add all that distance up. Write an expression for the area. The area is this shaded region here. How much area, how much of this region, how big is that shaded region there? Well, isn't area is length times width? So what's the length? Well, the length is 5w plus 3 times the width. So if we distribute there, we get 5w squared, w times w is w squared, plus 3w. That's the area. So this is my perimeter, that's the distance around it, and that's the area. Not too bad. The number of coins that Dan has in his pocket is 1 less than twice the number of dimes. Write an expression for the total amount of money. Okay, so I'm dealing with money here. Should have used a green pen. Dealing with money here. So let's read it. The number of quarters is, so quarters is 1 less than twice the number of dimes. 1 less than, so I'm subtracting 1 from something. Minus 1 of what? Twice the number of dimes. So 2 dimes. So the quarters is 2 dimes, and I'm taking away 1. I want to know how much money he has in his pocket. So he has some quarters, and then he has dimes, right? He has quarters and dimes in his pocket. Well, here's all the quarters. This is the quarters plus dimes. But here's the thing, this doesn't give me money. I need to turn this into money by adding in values in front of them. How much is a quarter? Quarters are 25 cents. So here's how many quarters I have. This is how many quarters. That 0.25 turns it into how much? How much money? This is how many dimes. I have d dimes. How many? If I add a 0.10 in front of it, because dimes are 10 cents, that gives me how much. So my final answer here is actually every quarter I have is 25 cents, and every dime I have is 10 cents. You could distribute and clean that up or leave it like that. But be careful. This 2D minus 10 has nothing to deal with money. It deals with how many. How do I make it deal with money is I added in that multiplier out front to change it into how much money Dan had. And the last one here, a garden that was originally a square, so I have a square, is being adjusted so that one side is doubled and the other is getting shrunk by 3. So that side got doubled, this side got shrunk by 3. So it's a square. I don't know how long each side is, but I'm going to call it x. One of the sides got doubled. How do I double something? Well, that became 2x. That became 2x there, which means that's 2x. The other side got decreased by 3. Well, to decrease by 3 means to make it 3 smaller, so subtract away 3. That's my new rectangle. So this is old. This is new. Create an expression for the perimeter. So what does the perimeter equal? The perimeter is add up all the sides, travel around it, and add them all up. 2, 4, 5, 6. I have 6 x's minus 6. I added up all those sides. The area is length times width. Multiply the sides. 2x times x minus 3. 2x times x is 2x squared. X times x is x squared minus 6x. So that's my area, and that's my perimeter.